Hello, my name is Yanlin Zhu. Today I'm very happy to present you a story from waste oils to your next flight trips. So first, let's take a look at these two yummy photos. French fries and fritters, they are popular foods that we can DIY at home or we can order from a restaurant. I personally like them. But in preparing these foods, a lot of waste cooking oil is generated and has to be disposed. Actually, in addition to these waste cooking oils, there are a lot of low value or waste oil streams. This includes the crop oils and animal fats. So here comes the question. What kind of value can we create from of these waste or low value oil feedstocks? My answer to that is a biofuel. Using a patented technology that was developed here at U of A, we can successfully convert these low value or waste oils into drop-in diesels. But what if we want more? We further decided to move on to the application of a more difficult direction, that is the biojet fuel, based on what we have achieved. What makes the biojet fuel different or unique from the common drop-in diesel? That is the cold flow property. As we know, plane flies high in the air, which can be up to 35,000 feet from the ground. And that high altitude, the temperature can be as low as minus 55 degrees Celsius. That is extremely cold. And common fuels at that temperature will form a gel or get frozen inside of the fuel tank, so it doesn't work. The reason for that comes from the structure of the fuel molecules. For common fuels, a lot of its molecules is in the straight form or linear form. These types of molecules can be orderly packed at low temperature, which will restrict their movements. So in this case, the cold flow property is not good. My work focusing on introducing branches into these straight molecules or side chains. With all these branches or side chains, these molecules will stay more active at low temperature, and in this case, they can get an improved cold flow property. We have been working for more than 1 year on this direction, and we have achieved promising results. Our final target focuses on the global aviation fuel market. As a current aviation industry, it actually contributed to 2.5% of the global CO2 emission, which is more than 1 billion tons of CO2 per year. And the global aviation fuel market is expanding very rapidly over time. As we can see, the total market is expected to be expand by more than 50% by the year of 2026, based on the 2018 level. This represents a great opportunity for the green technology development in this area, and I'm confident that our technique will become one of the cornerstones for the future of the aviation fuels. This project is currently led by Dr. David C. Bressler at the U of A, and we are very happy to have received tremendous support from all our collaborators that listed here. If you are more interested in the more details of this project, please feel free to reach out to me, or please refer to the websites listed here. Thank you.
Does anyone want a better battery for your phone? Has anyone experienced the horror that you have an important message to reply, but your phone is just dying? Or has anyone considered buying an electric vehicle but was worried about the limited mileage? The world needs better batteries, not only for EVs, portable electronics, but also for the intermittent energy storage for renewable energy systems. The world is electrifying. Renewable energy is expanding dramatically over the past years. Solar energy itself is expanding with a compound annual growth rate of more than 25%. The United Kingdom, Norway, State of California, and Henan province in China, among many other cities, are moving towards banning the sale of automobiles, gas-powered automobiles, in less than a decade. This global shift towards a more sustainable world is all underpinned by the technology development of batteries. My name is Bing Cao. I'm CEO and co-founder of Nanode Battery Technologies. Nanode is a spin-off company from the University of Alberta, and our technology is based on recent research from the University of Alberta Research Lab. I'm here to show you how nanode technology can make batteries better. Let me give you a crash course on lithium-ion batteries. A typical battery consists of three essential parts: the cathode, the anode, and the separator. The lithium ions then can move back and forth between cathode and anode, then we can charge and discharge the battery and use it. Believe it or not, in the past decades, most of the advancement of battery has been focused on the cathode material, while little research is given to the anode research. At Nanode, our technology is focused on the anode material development because, as you see from this picture, graphite, which is this black carbon powder, is used as the classic anode material in battery for more than 3 decades with minimal change. Now it has come to the time that the cathode material have so much been advanced. We need a better anode technology to match with it in order to make the batteries perform even better. Here is what we do. At Nanode, we make these thin-film metal-based ribbons to replace graphite. Our product not only offers higher energy density than graphite, but also our preparation method is much simpler. Let me explain. What happens for graphite anode preparation is we need to combine the graphite powder with some conductive binders, additives, and organic solvent, mix it together, form a slurry, then cast this slurry onto a copper current collector, then go through drying and calendering process before it used in the battery. At Nanode, our technology is much simpler. We go from raw material to the final product in one step. We don't use any organic solvent, and our process is dry. Also, the one-step process eliminates the variation that can be introduced in the battery manufacturing process. At Nanode, we adopted this technology called melt spinning. We can make these long and flexible metal ribbons in seconds. Then we cut it into shape and fit in battery manufacture directly. We have demonstrated in lab that our product is 50% better than graphite. Our team consists of scientists, engineers, technical and business mentors from University of Alberta. We are passionate about our technology and we will keep making progress. We are very grateful that we are supported by the community. The Government of Canada, Government of Alberta, the University of Alberta give us great support as we grow. So, if you are interested in your technology, if you want to know more about Nanode, if you want to keep an eye on our growth and progress, if you want to see future Alberta-made high-performance batteries, please keep in touch and contact us. Thank you.
Hi, my name is Zhongyi Kwang, and I am the founder and CEO of Electronic Grid Systems. We're a spin-off of University of Alberta. Today, I'm going to talk about the evolution of the electrical grid system and how it will look like in the future. For over a century, electricity has been an essential part of people's daily life. Without electricity, we cannot do anything. And the system that supplies electricity to our homes is called the electrical grid system. The first grid systems were built in the late 19th century. It all started with a current war between Tesla and Edison. We now know that there are two types of electricity. There's a alternating current, AC, and also a DC, direct current, DC. Edison developed the DC technology, where the current or voltage runs continually in one direction. Well, the Tesla, who once was Edison's employee, believed that AC is the right choice for the electrical grid system because compared to DC, AC can be easily increased to a higher voltage through a transformer, and therefore it can be distributed over a long distance. But back then, people did not know how to convert DC into higher or lower voltages. So the system was not efficient because the voltage was too low to distribute power over a long distance. And therefore, the winner of the current war was, of course, Tesla and the AC technology. Well, to recognize Tesla and his greatest invention, a statue of Tesla standing on his AC motor has been built at Niagara Falls, where the first AC power plant was built in 1895. Since then, AC has become the standard in our grid system, and well, we have been relying on that system for over a century now. Well, most people might think that the system will never change, but actually we're on the verge of a revolution in the electrical grid system. Because right now, we can convert DC power now easily with a device called power electronics or power converters. So power converters are a kind of system that can transfer electricity from different forms. For example, from AC to AC with different voltages, from AC to DC, or from DC back to AC, and also, of course, from DC to DC with different voltages. And the efficiency is very high. Sometimes it can be around 99% efficient. So power converters exist everywhere in your cell phones, chargers, all cars, whether it's gasoline or electric, in your home appliance, so basically everywhere that uses electricity. With power converters, we now can generate power in the DC form through, for example, solar panels, and we can even transmit power in the form of DC through high voltage DC transmission. With the development of power converter technologies, we started to think if it's possible to have a DC grid now. Well, the answer is yes, and because the DC grid can be even more efficient than the AC grid. For example, if we're talking about charging your cell phone, if we have a DC grid, then only one stage of power conversion is necessary, and that means higher efficiency, less energy waste, and therefore less emissions from the power generation. With the motivation to make our grid system more efficient and also more stable, lots of investments and research projects have been focused on the future DC grid technologies around the world, of course. And here at U of A, we have research projects in every aspect of the electrical grid system, and we have also developed new technologies to provide stable power to every home so that people won't be affected by any blackout events. And to better transfer our research into real world, last year we started up a spin-off of U of A called Electronic Grid Systems to commercialize our microgrid solutions to provide low cost and high efficiency all-in-one solution for home and business owners. And with our solution, the payback period will be much shorter, and also the system can be easily transformed into a DC grid without any additional cost. Well, currently we are a small team, but with lots of support from U of A, government of Alberta, and also government of Canada. And we are determined to make DC grid happen sooner. So don't feel surprised if you see a full DC grid in Alberta in the next 5 years. With that, thank you for watching my talk, and I hope you all enjoyed this video.